Welcome back, dear learners. We are going to continue with our revision. We'll be looking at question 1.1, which says, for the figure 1.1 showing stages in the development of a mid-latitude cyclone. Excuse me. So let us first go and familiarize ourselves with the mid-latitude cyclone. So this is the figure showing mid-latitude cyclone. You can as well see that we have X, Y, and Z here as well. They are different symbols. You can see this one in blue, one in red. And see the map of Southern Africa, Madagascar here, among others. All right. So our first question says, name the front at 60 degrees in the diagram X where mid-latitude cyclones develop. They say, name the front at 60 degrees in diagram X where mid-latitude cyclones develop. So going back to our question, the front at 60 degrees in diagram, this is diagram X, which says to name the front at 60 degrees. And as we all know, that this is the polar front. It is at the polar front where we're going to have different air masses meet, as we saw in some questions before. So meaning that 60 degrees would be our polar front. It is a front because a front, it is a region where different air masses meet. This could be, for example, warm air, and this could be cold air. So that's why we say the front at 60 is a polar front. All right. Number 2, name the stage of development of the mid-latitude cyclone at X. They're saying stage at X. So which is going to be a formative stage. If I try to remove these other drawings, so that will be a formative stage. As you can see, the front is just starting to develop. You see, if we compare, let me do this. If we compare the cyclone in this diagram and in this diagram, you can see there is a difference. See, so which means that this one was still in its development. It was still in its formative or developing stage. All right. So we are going to say this was a formative stage. This is F. Formative stage. Here we said it was a polar, or it is a polar front. Number 3, give the lowest air pressure recorded in stage Y. The lowest air pressure recorded in stage Y. This is stage Y here. And according to the diagram, stage Y is being shown by this diagram at this particular point. So we need to be very careful with the labels. So this is stage Y here, right? So that has to find out the lowest air pressure recorded as stage Y. Now, this is going to take us to the isobar interval or pressure interval. What do I mean when I say pressure interval? Let me check again here. Check again here. Okay, I just need a blank page to look at isobar interval. So this refer to the difference between two isobars. For example, if I can illustrate this down, you can see this could be an isobar, which could be 1000, and the next one could be 1004, and the next one could be 1008. So you can see that the difference between isobar A and isobar B, it is 4. Between B and the difference, it is 4. So we look at that, it can enable us to be able to give the pressure difference. What do I mean by that? So see here, because I could ask you, what is the pressure at point X? See, so the mere fact that we're dealing with isobars, this is pressure. You'd be like, okay, at A it was 1000, at B 1004, at C 1008, then at X, of course, since we are adding up 4, suppose it's going to be 1012, because we're just adding 4, meaning that the difference between these different isobars was 4 MB or 4 HPA. I'm saying 4 MB millibars or HPA, which means, or which stands for hectopascals, or MB, which stands for millibars. All right. Now let's go back to our question after getting more clue regarding that. So the question says, give the lowest air pressure recorded in stage Y. The lowest air pressure recorded in stage Y. If I try to zoom in, sorry, let me try to go back. Okay, lowest pressure recorded in stage, this is our stage Y here. We're going to use the isobar interval. So it means we need to find out, because this is stage Y here, right? So the lowest, this is an isobar. But what could this isobar be? And what could this isobar as well be? But since we know there's an isobar here, which is numbered 1008, and since this is a low pressure cell, we know pressure decreases towards the center. If this is 1008, you can see 1008 here. This is 1004 if we refer to this, which means that if this was 008, this is supposed to be 1004, and mean that this one is going to be 1000. You see, so it shows that pressure is decreasing from 1008 to 1004 to 1000 HPA or MB. So it means that our answer for this case is going to be 1000 HPA stroke MB. All right. 114. Which mid-latitude cyclone Y or Z is older? Let's go check. Which mid-latitude cyclone Y or Z is older? If we check between Y and Z, this side we have this is Y and this is Z here. All right. But don't forget, we as well come back to where these diagrams were taken from. Remember, this is y, at this point, and this is z. Right. So if they say between y and z, which one is older? Okay. So it means our answer is supposed to be z. But how do we tell that it's going to be z? All right. So supposed to be z. How do we tell that? Let's go back to our diagram. Remember, we know that mid-latitude cyclones, they move in such a direction. We say they move from west going to the east, or to the easterly direction. Therefore, we say if we look at y and we look at z, we compare between the two, and we ask ourselves a question that which of the two has already reached in the east. If you look at this, it means that mid-latitude cyclone Z has already reached the eastern direction. Sorry, which makes it to be the oldest. So, always the one which reaches the east first, it is the oldest mid-latitude cyclone. That is why for this case we are going to say that Z is the oldest because it is already in the eastern direction. All right. Number 5, name the stage of development of mid-latitude cyclone at Z. This is our Z here, which has been enlarged this other side, right? But you can see at this particular point, there is a cold front, there is a warm front, there is a cold front. Whenever you see such, where you see a cold front, warm front, cold front, warm front. This is typical of what we call the occlusion stage. The occlusion stage, meaning that the cold front was able to catch up with the warm front. So that's what happens when the cold front do catch up the warm front. So we say it will be the occlusion stage. All right. Number 6, what evidence suggests that the illustrated mid-latitude cyclone is in the southern hemisphere? So how do we tell that the mid-latitude cyclone is situated in the southern hemisphere? Let me try to remove this so that we can see clearly. All right. Okay. Okay. So what evidence, or let's the question, what evidence suggests that the illustrated MLOC is in the southern hemisphere? What can we look at here? Firstly, can talk about countries like Madagascar, situated in southern Africa. Okay. Can I as well talk about the rotation? Rotation is clockwise. Sorry. Rotation is clockwise. See? As you can see here, you see the arrows which are rotating in clockwise. direction, and this is typical of low pressure cells in the southern hemisphere. All right. Let me try to go back to the question so I can write the answer there nicely. Okay. This is the blank page. Say, let's close up here. Let's talk about. Sorry, my challenges with technology, However, let's go back to the question. Was saying, what evidence suggests that the cyclone is in the southern hemisphere? And we said 116. We can look at the 60 degrees line of latitude, latitude, because this S indicates that we are in the southern hemisphere. As well look at the part of southern Africa, can as well give the clockwise rotation, which is in this southern hemisphere. Let's check again. Talk about the rotation. Talk about the static line of latitude. Talk about part of Africa. And as well talk about, and we say that the home front is facing northwards. Let's say the home front is facing northwards, and the cold front facing southwards. All right. Okay, let us proceed to question 1.1.7. What is the term used to describe mid-latitude cyclones that are linked to one another? Linked, as you can see here, two links that connect. There's a cold front, there's a warm front. The cold front, there's a warm front. The cold front, there's a warm front. So we are seeing a series of different mid-latitude cyclones that are linked to one another, and this is commonly referred to as a mid-latitude family. All right, let's proceed to question 1.2. They say, choose the correct word from those given in brackets, which will make the sentence true. Write down only the word next to the question numbers 1.2.1 to 1.2.8. All right. Let's choose the page for this. So 1.2.1, they say rivers that flow all year round, all year means all the time, going to be referred to as the permanent rivers, because permanent means it is always going to be there. Then exotic dash periodic rivers flow during the rainy season, which means this would be the periodic rivers. It means they are periodic because they flow in a given period of rain. That's why they are not like the permanent rivers. Permanent rivers do not have a season. They flow all the time. But periodic, they have a certain period when they're supposed to flow. Number 3, rivers that only flow after heavy rainfall are known as episodic rivers. So episodic, they only flow when there is a heavy rainfall. Reason being that these rivers are never supplied by the base flow or by the underground water. That's why they must wait for the heavy rainfall, then they can as well flow. Number 4, the majority of rivers in South Africa are periodic rivers. This is being evidenced whereby the amount of rainfall is less, and as well South Africa is a water scarce country, meaning they've got less of few of permanent rivers. Most of them are periodic rivers. That is why during times of drought there is scarcity of water. So it is the reason why we say that most of the rivers or majority of the rivers in South Africa are periodic rivers. Number 5, in permanent stroke episodic rivers, the riverbed is always below the water table. That's going to be the episodic river. So in episodic, the riverbed is always below the water table. If we try to illustrate this on this one here, this is our base flow. I spoke about this one sometime before, and we said the upper surface of this is the base flow. We can say base flow. Then this is the water table. So rivers whose bed cannot reach the base flow. This is the river bed. So these rivers, we call them episodic rivers because they are never supplied by the water table. Let's check the question once again. It says the water table is always below the river bed. Like I showed you here, this is the water table. This is the river bed. So when they say the water table is always below the river bed, this is the bed, yeah, and this is the water table. So such would be common in episodic rivers. Number 6, water table is always okay. So if this one we said it's going to be episodic. Number 7, periodic exotic rivers flow all year round because they are fed by tributaries in high rainfall areas. So that would be exotic rivers. With exotic rivers, their origin, the water table is always above the riverbed. If I show you here, for example, this is the water table, for example. So this is the base flow, and this is the water table. If you show our exotic river, you can see that with exotic rivers, this is the water table, WT, front water table, and this is the river bed. So you can see that in exotic rivers, the river bed is below the water table. The moment it is below the water table, it means that this river will be supplied by the underground water or by the base flow, which makes it to be able to flow all year round. In 1 to 8, permanent stroke periodic rivers are characteristic of interchanging seasons of high and low rainfall. Now let's check and see. So it's going to be periodic, interchanging seasons of high and low rainfall. All right. Okay, let's go to figure 1.3, which says is a diagram showing the influence of the plateau on South Africa's climate. Let's check figure 1.3. So figure 1.3, As you can see, this diagram A, diagram B, high pressure, inversion layer, warm moist air, the escarpment, and the plateau. The same here. All right. Let's go to the questions. They say, does sketch A or sketch B indicate winter condition? Which sketch between A and B does indicate winter condition? I'll give you 3 seconds to think about that one quickly. So our answer is going to be sketch A does indicate winter conditions. Why do we say so? Let's just go down here. To illustrate evidence to show winter condition, you can see in winter condition, the inversion layer is below the escarpment. So the inversion layer here. Inversion layer. So it is below the escarpment, blocking the warm moist air. Warm moist air blocked. It can't reach this is the interior here. So this warm moist air from the ocean cannot penetrate through this point because the inversion layer has been pushed further downwards due to stronger subsidence. Therefore, we say that diagram A represents winter conditions. As you can see here in the diagram, the inversion layer here, it is below the escarpment. Right. And you can see we have a strong subsidence there. Strong subsidence forcing the inversion layer below the escarpment. Then number 2. Wow. Give evidence for the sketch to support your answer. That is 113. So we said this one is supposed to be A. Give evidence from the sketch, and we say inversion layer below the escarpment. And as well as say warm moist air is blocked. They only need one reason or one evidence. All right, number 1.3.3. How does the inversion layer form in sketch A? How does the inversion layer form in sketch A? So we could say this forms due to strong subsidence, descending on a weaker warm air. Right. 134. Account for the change in the position of the height of the inversion layer in sketch B. Account for the change. Question 135 says, write a paragraph of 8 lines explaining how the changing position of the height of the inversion layer over the plateau influences the climate of the interior of South Africa during winter and during summer. Okay, the climate during winter and summer. It's 135. So this is gonna be 135. Let's start with summer. So that in summer, inversion layer is above the escarpment. This allows warm, moist air condense forming overcast clouds. As well, there will be heavy rainfalls and thunderstorms. Okay, so this is for summer. Then winter. In winter, inversion layer is below the escarpment. This blocks the warm, moist air from not reaching interior. There will be clear skies and no rainfall. Right.